Hello and welcome to Beginners Python and Machine Learning. My name is Tim Cummings, and this is a meetup group for introducing people to the Python programming language and also some machine learning principles. So I'm not going to be talking about machine learning myself. Tonight we're going to look at Python, the programming language, from the perspective of an absolute beginner who's never seen it before. Now, the advantage of these live sessions is that you can talk to us through chat. So we've got the YouTube chat here that I'll be listening to, and I'll also be listening to Slack. So there's instructions below the video explaining how to get linked into the our Slack channel, and we'll be learning to code. Where the one I'll be watching, so you can ask questions there. All right. So I've got quite a few people have responded to coming along tonight's session, so that's great. And really, the questions are really important. I'm going to be talking about these things, but we're talking about functions. But that's really just a way of having a topic to talk about and just introducing things, and then as we come across things, then you can try, it might spark some questions that you want to ask. All right, now we're going to be using Google Colab for tonight's session, and that means you don't even have to have Python installed on your computer. It's a fantastic way. I still use Google Colab myself, even for advanced stuff. It just quickly brings up a Python environment, and you can quickly run some commands and see how things work. So I've got a link here. So the link, there'll be the same link as in the YouTube video, below the YouTube video. And so if we go to that link, we'll open up a new tab. And this is our Google Colab session. So this is the one that I've shared to you. It'll have the same URL up here. But you won't be able to make any changes to it. So what I suggest is that you make a copy to your drive, and I'm going to do the same because I'm in a different account to the one that created it, so I can't make changes either. So click on copy to drive, and this one creates a brand new Colab worksheet saying outputs will not be saved because I've turned them off, so we can close that. And I'm going to share this one with you as well. So you can actually, through tonight's session, if you want to find something that I've typed in, you can refresh your copy of this link and you'll see exactly anything I've typed in. So let's copy that link. Now it's shared to anyone with that link. And there it is, and I'll try sending it to YouTube chat. Hopefully it'll get through. YouTube often censors out anyone sending URLs, but there you go. You can see I've sent it, so hopefully you can receive it. All right, so let's see how we use Google Colab. Google Colab's made up of code cells and text cells, and it's just text cells is just where I've typed some stuff here. So I've typed all this bit at the beginning saying what we're doing tonight. We're going to have a look at interactive Python, doing a bit of coding, and having a look in particular in functions. So we'll scroll down. Oh yeah, so I've got, if you want to use Python on your computer, you can do this through Colab, which is what we're doing tonight. You could also install Python from this link here. Alternatively, you can install Anaconda, which includes many third-party libraries, but I like having a clean Python and just install the third-party libraries when I need them, rather than just having them all sitting there not doing anything. So that's the one I recommend. And I also, in my work, I do use an integrated development environment, and I use the free community edition of PyCharm that you can get from JetBrains. A lot of people also use Visual Studio Code. For those interested, I've written a Python coding course for kids at python80.com, so you can check that out. It's not actually working right at the moment, but this weekend I should have the website updated with the working version that I've got going, because PyCharm have updated their educational tools that it uses, and it broke my software. All right, so different ways to write Python. You can write it as Python scripts, or you can write them in notebooks, and so we're doing notebooks tonight. Jupyter Notebooks is what this is in Google Colab, and Jupyter Notebooks is an extension of IPython, which stands for Interactive Python. So it's really anything you can do in Python, pretty much you can do in Interactive Python. And the advantage of Interactive Python is you can see the results straight away, and it's a fantastic learning tool. So I really recommend this as the way of learning, and even when I need to learn some feature of Python, then I will use an Interactive Python. We've also got a Python version of this notebook available on GitHub, and this is the repository. I've just renamed it, so the old URL should still work, but apparently this is now the new URLs, and so you can get it from there if you want to look at the Python scripts rather than the notebook version. All right, so how do you use Google Colab? You can just type into a cell. When you've finished typing into a cell, you press Shift-Enter to execute that cell, and see the results. So here are some code cells. This is talking about code cells. This is an example of a code cell. So you can see I can click in the cell. I can start typing if I want. Anything that I type there will go in. Now, all I've put in this cell at the moment is some comments, and in Python you start comments with this hash symbol. So it just ignores anything after the hash symbol, but it's useful for when you're looking back over your code to wonder what you were trying to achieve. It's also good for disabling code that you don't want to run all the time. Now in this case I've used it for disabling this line here, so I'll get rid of the comment for now, so I'll enable it, and you can do that on your copy as well. And it's a question mark, and the question mark is how you bring up IPython help. So I could press Shift Enter now, or I can press this play button. You can see run cell or Control Enter. So let's press play, and now the first time you press play, it'll connect you to a computer in the cloud. So Google have given you your own Linux computer running Python and running this notebook. So it'll have a certain amount of RAM and a certain amount of disk space, and now it's connected. There's the RAM and disk, so we're all pretty low on that, and it's running. So that was just a bit slower for the first one. All the others should be a lot faster. And here's our help on how to use IPython. So you can read through that if you want. So I'm just going to close that. Now if you there's also, you can look up all the keyboard shortcuts in Google Colab if you want to see all the different things that you can do, like Shift Enter or Control Enter. So they're all there. I'll just tell you the ones that I use as I use them, and it's not that many. All right, let's I'll put the comment back in front of that. And so I've put the comment back and run it again. It'll now says we've run 2 cells and nothing happened. Okay, so introduction to coding. When you write a program, all you're doing is just giving a series of commands to a computer to do, and it just really starts at the top and works through them and does each one as it comes to it. So we've got 4 lines in this cell, and the first 3 are comments because they start with a hash, and then on the 4th line we've said print 5 plus 3. So that's a command we've asked the computer to do. So if I run this cell, it'll look at 5 plus 3, it'll add them together and get the value 8, and then it'll print that 8 to the output here, which is just after the code cell. So that's what you'd have to do in Python, just a normal Python script. But in IPython it's even easier. You don't even need the print command. You can just put in something like 4 plus 5 and it will display the result of 9. So you can see already we can use Google Colab as a simple calculator, and it can handle very big numbers and very accurate numbers as well. So it's quite can be quite useful as a calculator. Now, if you have several commands in a cell, they're executed sequentially. So if I say print 4 on one line and then print 3 on another, and I run that, it prints the 4 and then it prints the 3. So just one after the other. Now, unfortunately in IPython, when you want to display the results, it'll only display the results of the last line of the cell. So if I say 2 on one line and 1 on the other, the result is really just 1. The 2 just gets lost. So if you want every result that you want to display, you have to put it in a separate cell in IPython, but that's not too much to ask. All right, so how are you going? Is this making sense? I'm really looking forward to some questions. Hopefully you're able to execute these cells. Tell me if it's not working. Okay. All right, now let's look at variables. Because we do an absolute beginners session here at the first week of every month, so I'm just going to go through some really beginner concepts here for Python. And one of them is variables. And variables are basically memory cells that you store. Okay, we've got a question, so that's fantastic. How to create a separate cell, and it's quite easy. So I'll just interrupt here. If you hover over between two cells, you'll see you'll come up with code and text. So you can add a text cell or a code cell, and it even gives you the keyboard shortcut Control M and B if you want to do it from the keyboard. So if I click on code, I can just keep clicking on code and create some new cells. So then you can try doing some things and then run that, and it'll calculate it for you. All right, back to variables. Variables are memory locations, so we can just name them whatever we like, as long as we don't clash with some of the built-in names that Python has. It has a few reserved words that we can't use, but if you use one, it'll tell you, so you'll be fine. All right, so let's create a variable called x, and we'll store the number 3 in it, and then we'll create a variable called y, and instead of putting in the number 3 or putting in a number, we're going to put in a formula that it's going to calculate, and once it's calculated the result of that formula, it stores that result in y. So let's have a look at what x and y are. So x equals 3, y equals 1. Now y is just storing 1. If I change the value of x, y will still be 1. I'll have to rerun this formula and assign it into y if I want to get a new value there. All right. How did we go? No more questions there. That's good. Okay, so we can calculate y for different values of x and put all the x and y values into lists. Now in Python, a list is just designated by these square brackets. So I'm going through this pretty quickly because we're really wanting to be looking at functions tonight, but I'll just introduce you to a few of these data types. So we use the square brackets here, and we say that's an empty list, it's got no data in it, and then we can go through a loop and append all this data into the list, and we'll have a list of x values and a list of y values. Now I'm showing you this quickly just so that you get an idea of what a Python program looks like. So notice how Python uses indentation to designate code blocks. So this here is a loop, and all of that is indented after this colon. So we have a colon, means start of a code block, and then All the lines after that you would indent, normally by 4 spaces, which is what we've done here. And then they'll get run in a loop over and over again for 41 times. And then this line here will only get run once it's outside the loop. So that's just introducing you to the concept of indentation. Now, Python's one of the only language I know that uses that. Oh yeah, please elaborate on f-string. That's a very good question. All right, so I'm using f-strings here for displaying information. So if I want to create a string, I can, so let's see, s equals y equals, and that's my string. All right, so let's have a look at that. And so I'll display what's in s. So a string is just a series of characters, and it just says y equals. That's all that's in it. Now, say I want to put a value in there of one of my variables. So I can use what's called an f-string. And f-strings are really powerful ways of formatting data. So you just stick an f outside your quotes there, and these can be double quotes or single quotes. And then inside the quotes, you put the curly braces, and then you can put in what variable you want to display, and then it'll evaluate what's in the curly braces and replace them with that value. So now it just says y equals 1. So that's the power of f-strings. You can, I can say 2 times y. Then I'd have to put 2 times y out here if you want the string to make sense. And 2 times y equals 2. Now, they found that people were doing this quite often, so they provided a shortcut. You don't even need to put that out there. You can just say 2 times y and then equals, and it'll evaluate that expression, and then it'll put it equals, and what the result, it'll say what the expression is that it's evaluating, and then an equals, and then what the result is. So that's pretty nice. So I use them quite a lot. So 2 times y plus 6 equals 8. And so here I've used, I want to know what the value of x is, but I want it labeled, so I've done x and then the equal sign to label it. I want to know what y is, so I'll put a y there. I want it labeled, so I've put the equals there. So x equals 3, y equals 1, and this comma, that's just standard string. That's just that comma in the space. That's just come from what I've put in there in the f-string. All right, so you're going to see a lot of f-strings tonight. If there's any questions on any particular thing that I've done with an f-string, let me know. Yes. All right, so here we're going to create a list. There we go. Another question. Fantastic. Sorry, in the custom, did you set y? Yeah. So yeah, y was set up here, and in fact y was set here, y equals 1, and even though I ran it in a cell that's above the cell that y got set in, it depends on the order that you run the cells. So you can see that this cell was run number 8 and this cell was run number 13. So because it was run after this one, it knows what the value of y is. And that's why we use variables as well, to store information that we can then use later. So now we're going to do this. We're going to run this loop here, and it's going to go through 41 different values of x and calculate 41 different values of y and store them in these lists. And I'm going to print out the first 10. So you can see I've got another indent here. So anything in this, if anything that's indented here will only occur if this is true. So if I is less than 10, it'll print out x equals and y equals, and then it will display the full lists. So feel free to change any of this code as well and see what the results are, because you can always go back to the original here with the unadulterated code if you need to get back to what the original was. But the way you really learn is by changing things and seeing what the results are. Okay, so I've got this print statement happens 10 times for the first 10 values of x, and then after that it keeps looping the 41 times, 31 more times, and then prints out the full value of x and y. And this is what a list looks like. So you can see x is looking good, 3.1, 3.2, 3.3, all the way up to 4.0. So the reason it's 41 values is because it includes 4.0 at one end and 0.0 at the other. And this is the calculated values of y. These all look good. There's something a bit awry going here, but we'll talk about that later. Is there a way? So line by line is really cell by cell. You just put one line in a cell and see what's going on, and then you go and you just create a whole bunch of cells and run each one as you go. Now, if you're using a integrated development environment like PyCharm, you can invoke a debugger that you can pause on each line, have a look at what the values of all the variables are at each point, and I find that very useful as well. But you need an IDE to do that easily. So this, yeah, it would be difficult. You couldn't do the loop. The loop all has to be in the one cell. So you can't use Google Colab to step through each line in the loop and then go back and keep going around the loop. So you would need a debugger to do that. But what you could do is use print statements, or more advanced, you use logging statements to log out values at each row, so you could see what's going on. In fact, that's what we're doing here. I only want 10 of them, so I don't get too much data. But I'm saying, how is x? X starts off as 0, x, y, x, y, x, y, x, y. So we can see how x and y are being calculated inside the loop. All right, now we've got all our numbers in these two lists of x and y values, and we can actually plot them using a third-party library. So to use a third-party library, we'd have to install it and then import it. Now, because Google Colab is based on Anaconda, Anaconda has already installed Plotly for us, so we can use it even though it's not a standard library. But we still need to import it. So importing it means we can then use it, and we're going to import it and give it a different name when we've imported it. We'll call it px, and then we can just use this abbreviation px.line. It says draw a line chart using our x values from our list of x values and our y values from our list of y values. And there's a pretty chart that we get that shows all the calculations. You can hover over different values there and see what the x and y were at each one of those locations. You could even zoom in to different parts of it, and if you look up here, you can see things that you can do, like you can reset back to the original values. You can zoom out, zoom in, you can pan, and you can zoom. And so the zoom, you can create a bit that you want to zoom in on, and there it is. All right, so it's pretty powerful and fun to play with. Okay, so we created that by looping through a function x squared minus 4x plus 4 and calculating y for that every time. but that can become cumbersome and error prone if we have to write out the function every time we want to use it. So we store it in a Python function. So the way we define a function is we use the Python keyword def, which means define a function, and then we make up a name, and I've just made up a very simple name here. I've just called it f, and then we say what are our arguments to this function, and it'll use those arguments. So like our x value here, it'll just substitute in whatever value we put in there. It'll put it into a, and then we can run that formula. Now I've used a instead of x just to show that it can be different. It doesn't have to be an x. And now if I run this cell, it will define the function, but it doesn't actually run the function. So if you want to run the function, you have to do what's said calling it. And to call a function, you do the function name, then parentheses, and then the value that you want to pass into the function to get the return value. So if we put a 5 into the parentheses, it'll set the value of a to 5, it'll calculate all of this using a equals 5, and then it'll come back with the result of as a number. And in this case, it's come back with the number 9. So it's gone and done 5 times 5 is 25 minus 4 times 5, which is 20. So that's 5 plus 4 equals 9. And so it's got the right answer there. Okay, so we set a task here for you. So this one you have a go at yourself. Call the function using an argument of 2.5. And I've even left you with a blank cell to have a go at it. So you can either quickly go and do it now, or you can pause the video and have a go and then start the video up again, because I'm going to go straight into the answer. And here, quite easy to call a function. You just do the function name as you saw above. You put in the value that you want to pass through as an argument to the function, and then you run that by pressing the play button. And the answer comes back as 0.25. Okay, what is the scope of the function? So that's a good question. So we're in Google Colab. The scope, this function, it can be used in any cells that are in Google Colab. Now if you're in a Python script, you could create different modules, and so the function could be used in that module, or if you wanted to use it in another module, you have to import it. So a module is like a file with all your Python functions in it. If you're in a class, you can put all of your functions into a class, like object-oriented programming, and then you can call a function on that class, like a method. Okay, so here's our solution. I better check. No one's asking anything on Slack. No. So the solution is a longer way of doing it. So we've set our variable x and put 2.5 into x. We called our function f of x. What's the value of f for that value of x, and stored the result in our variable y. And then we've printed it out using our f string to say f of x equals y. And we should get the same answer, which we did, 0.25. All right, so Python is dynamically typed, so we can have different types in there. So we can have, well, let's have a look. So here's, I'm putting the number 3 into x. Here I'm putting the number 3 dot. So what's the difference between these two? Let's run it and see. So that in the first row, the type of x was int, and the type of y, that's the result of the function, it also comes back as an int. And you can see, so f of 3 equals 1. Now if x was a floating point number, and the difference between ints and floating points is just that floating point have got a decimal point, and obviously you can have fractions of an integer past the decimal point, and it knows that x is a floating point number, and when y gets calculated, the result of it will also be a floating point number. Now, the way I've shown that is using this really complicated f string, and one of the things when you're writing code is if you see yourself writing the same bit of code over and over again, then that's a good time that you could want to use functions. So I could just put all that code into a function, and then whenever I wanted to run it, I can just call that function. Now, if you want to try to understand what this code is doing, you just try to break it up into smaller parts. So it's an f string, so you've got the anything in the curly braces is going to be evaluated. Anything outside is just straight text. So Google Colab has very nicely color-coded that for us. So all the red here is straight text. All the curly braces are going to be evaluated. Okay. Now I've also, we understand what these two do. They're just showing the values of x and y. Here I'm evaluating the type of y, and then I'm looking at a particular attribute of what gets returned by the type of y dot name. So that's double underscore name, double underscore, and in Python that's a common thing for private attributes, and so we call that dunder. So that'll be type y dot dunder name, so dunder for double underscore. And then the other thing I've done here is I've put in a colon inside the curly braces, and anything after the colon is a format of how you want to display the result that you've calculated before the colon. So I've said I want to display it 7 characters wide, and it's a string. So that's what 7s means, and you might see some other formats that I use through the night. Okay, so let's create a function to make printing return value and type easier. So let's call it print function result. And in Python, the convention is to use all lowercase letters for the name of your function and separate the words by underscores. Then I'm going to have 2 variables. One I've just called fun, and the other one I've called x. So fun's going to be my function, and x is going to be the value that I want to apply to the function. And I can actually pass functions through as arguments to other functions, and then I can run it, as you remember, by using parentheses and putting x inside the parentheses and getting my value y, and then I do this complicated f string. So let's define that function by running the cell and then trying it out with a couple of different values. And we get the same result, and it's a bit easier to read as well. Print function result f of x for those 2 cases. Okay. Task 2, try calling the function with a different argument of a different data type. For example, decimal.decimal 1.1 from the standard library decimal, which needs to be imported. So that's our task. I've put the import statement into the task so we can just run it so that it's imported for us. And let's try it. So I'll try calling the function. I can do, actually I'll just call the simple function for now, f, and I'm going to pass it to it, my decimal. So I call the module name that decimal is in, then I call the class name and pass it the value 1.1, and then I run it, and I'm just going to use shift enter this time. And it came back with a result of decimal 0.81. So that's very nice. I've passed in a decimal and it's returned a decimal. So the decimal will always return just when you're displaying it. It'll just display it with decimal rather than decimal.decimal, because it doesn't know how we've imported it. We could have imported this a different way where we could just use decimal straight rather than having to always prefix it with decimal dot. Okay, let's have a look at the solution. From decimal, import decimal. In fact, so this is the other way of importing from decimal. And in that case, we can just say decimal 1.1. And when you're using the decimal function, you, as a decimal class, you pass in your strings, your data as strings, because you can't pass them in as floating point numbers, because their floating point numbers are stored in base 2. And if you and so they're not exact representations of the decimal, and the whole point of the decimal library is to try to use exact representations. So we can do it. A string will give us an exact representation of what our decimal number is, and it'll convert it from there. So they want us to use strings, which we have done in this case. So let's run this and have a look at the results. So if we pass in a decimal, we get an answer of 0.81. If we pass in a floating point number, which remember is stored in base 2, not base 10, then it calculates it out. The value coming in was a float. The value calculated as a float. When we display the float, it has this rounding error. That's just called a floating point error that you get when you're trying to use binary numbers to store decimal numbers. So if it's really important that you don't get this sort of result, then use the decimal class. It's not as fast as just using floating point numbers. So floating point numbers are great for scientific applications, and decimal is great for accounting type applications. Okay, task 3, rewrite our loop from before, which created list X and list Y, but this time calling the function rather than typing in the formula in the loop. So we had a loop back here, so I'm just going to copy and paste. Don't really need that first x equals 0. So we start off with an empty array, empty list for both x and y. We calculate, and this one we want to use a function rather than that formula. And yet we get the same results. So I hope you managed to get that task down. It wasn't that hard. Okay, we've got a question. This is fantastic. What is from? Okay. So from is here, from decimal, import decimal. So if we do import decimal as we've done here, we go to the decimal module and we import everything from that module into, so we can now use it. It's basically in our namespace, but there's a few things in there. I don't know what they are off the top of my head, but I know that this class decimal is one of them. So everything that I've imported, I have to prefix with decimal dot to use it, because it's imported everything. Now, there might be nothing else in that decimal module that I need. I only want to import one thing. So in that sense, I can do this. Rather than saying import decimal, I can say from decimal, so it's the same decimal. Only import one thing, which is the decimal class. And then because I've done that, I've only imported one thing. I know I've specified exactly what it is that I've imported. So I can now use that without having to put decimal dot in front of it every time with the lowercase d. And I can just use it exactly like that. And you know, there's other things that you can do. You can even use aliases if you want to make it even easier to use. So I could say from the decimal module, import the decimal class, but give it a new name, D. And then I can just say D of 1.3, and that will create a a decimal from this, as D. As D. I'm going to type it properly, as D. So I've created a decimal there just using this alias D. So that's just another form. These are all different forms of the import command for using items that are in different libraries and modules. Okay, so you can see the lines of code that we wrote here to create our X and Y and append it into our list and see the list at the end. Now, Python has a thing called list comprehension, which is a bit of a shortcut on all of this because this is a fairly common thing that people need to do. So inside your square brackets, you say I'm creating a list. I put my for loop inside the square brackets. So that's the same for loop as we had up here for I in range 41. And then I put in what value I want to store in the list here in front of the for loop, and so that's where I create my list of X, my list of Y, and so just in a couple of lines rather than all the lines I had before, I can create the same lists. So that's a little bit more advanced, but you know, if you're coping all right so far, then I thought I'd show that to you so you can, if you do see it in code, you've got some idea what's going on. All right, so Python's got built-in functions, just like the functions we've been defining. And so anytime that we've got a function name and you're calling it with parentheses, then that's the way you're calling a function. So here's our print function. We call it with no arguments. That just prints a blank line. We call a print function with one argument, which is a text string, the letters HELLO. And that will print out HELLO. All right, task 4. What other built-in functions have we already used? So just go back through and have a look at them, and I've just listed them here. So there was one range. We used range with the stop value. So the range function starts from 0 and goes upwards up to but not including stop, and can be used in a for loop. So it creates it's an iterable value that it creates. Type, we've used types to find out the type of what values we've been putting into functions and getting out of functions. We use the plotly express px.line to create a graph. So this is not a built-in function that came from a third-party library. That's why it needs to be installed and imported, but Anaconda installed it for us, so we didn't have to do that. But if you're on just straight Python, you would have to install Plotly, and there's easy ways of doing that. Decimal, now that's not really a function, it's a class, and what the convention is in Python is to use title case for classes and lowercase with underscores for function names. But Python's been around a long time, and it didn't start off this way, so this convention is not followed 100%. So you're going to find times when classes are in lowercase, and I haven't seen any functions in title case, but I've seen functions in camel case, just like Java does in JavaScript. Okay, so functions don't need to have arguments, as we saw before with the print. Let's have a look at another function. This one's in datetime. So datetime is a standard Python library. So we need to import it. It's not a built-in library, it's a standard one. So built-in ones don't need to be imported, but standard ones do. And standard ones don't need to be installed. So we've got access to this one in all our Python installations. So in that library or module, we've got a class called datetime. This is one without a capital D and T, and it should have if it's a proper class, but it's been around for so long, before title case became the standard. And then we can call the function now on that class, to return the current time, and then we can call a function or a method on the result of that time to format it how we want. So this is what we're going to do. We're going to format in an using an F string. No, not using an F string. We're using a string format time. Using %y, %m. These are the format commands for string format time, and convert it all to a string and then print that. And then that's stored in a function show time. So we have to call a function to actually run it. If we define the function, it doesn't get run unless we call it. Okay, and there we have. We split up the time into year, month, day, hour, minutes, seconds, and that's the time on the Google server. So that's 8 o'clock in the morning. So they're 10 hours behind us. So they must be on UTC time. All right. Now function. So that was a function doing something, which was showing the time. We've also have functions can return values, as we've seen before. So here we're going to define a function time zone regions that's going to give us all the regions that there are time zones. So one of the problems with doing demonstration code like this is getting data to use. So I've used the Pi time zone library because it's got a list, includes a list of all the time zones. So it's just some data that we can use on to write our programs and try different things. So it's going to go through all the time zones. It's going to split. It's going to look for them using the index function for a slash. If it finds a slash, then it's going to just return the value before the slash, which will be the time zone region. If there is no slash, then the whole time zone is the region, and that's going to return a list of sorted regions, which is another function, sorted. Okay, so let's have a look at the regions. So here we are, Africa, America, Antarctica, and so on. All right. So here's a bit of a challenging task for you. Define a function which takes one argument, the region, and returns the time zones in that region. Okay, so it's going to be pretty similar to this. It's just a sort of opposite. So let's have a go at this. So we want to go time zones for region. And we'll pass in what the region is we want. So we're going to create a set. This time the set's going to be called, we'll just call it zones for the time zones. We're going to go through each of the ones in all time zones. We're going to look for the slash. We'll see if it equals, we'll just call it R. And that'll split up that string and just take everything up to, but not including the slash. And if there is no slash, then R is just the time zone name. All right. Now that we've got R, we want to compare R to our region. And if it is, then we'll add it into we'll add the zone into the into our zone set. So let's call the zone the full name. So we've already got that. That's in the TZ variable. So we'll just add that. Now our sorted zones is just going to be our sorted from here, and that's what we'll return. Okay, so there's defined a function, and you can see the end of the defined function is when we are no longer indented. So these are all indented for spaces. Now I'm going to go back to not being indented. I don't even need to leave a spare line, but I do want to call the function now. and I want to find all the time zones in the region Australia. So that'll run through, and this has found all the time zones for us. By going through this code, it's looked at every time zone, it's see if it starts with Australia, and it shows the results there. Now let's have a look for New Zealand, see how many time zones there are in New Zealand. Time zones for region. And there's only one time zone in New Zealand, and because there's only one, they don't even put a slash there, which is why we had to search for these two cases. Is there a slash in the time zone or not? All right, now that was pretty quick. If there's anything in there that you want me to go over in more detail, I can do that. Okay, so that was a quick solution to task 5. Let's have a look at the solution that I provided earlier. So what I've done is I've split the function up into the different parts, because there were some parts that I wanted to use again, and like I said before, we don't want to be rewriting code. So this bit here, I was pretty much rewriting all that code that we did before, so why not put that away in a function itself. So given a time zone, have a function that's the region for that time zone, and that just looks for the slash and calculates the region, and then I can use that both in when I'm looking for all the time zone regions and when I'm looking for the time zones for a region. So time zones for a region, which is what we were asked to do, I just use list comprehension here, which is a bit quicker. So it's just a list of all the time zones for, and there's my loop for going through each time zone in pytz.all time zones. If, and you can put an if statement into your list comprehension as well to filter out the ones that you want. The region for that time zone, so we just called our function up here, equals the region that was called for this function. So just in one line, I've now got a list of all the time zones for that region. And similarly, in one line, I can do find all the time zone regions. So this one is not using a list comprehension, which is the square brackets. It's using set comprehension, which is curly brackets, but not like a dictionary, which has keys and values. It's basically just values. So set comprehension, find the region for the time zone, for every time zone, and I don't need to filter that because sets automatically eliminate non-unique values. And then I've passed that as my argument for the sorted function, which will convert a list or a set or a tuple into a list in order, alphabetical order. So it looks like more lines of code here, but you'll notice most of the lines of code are comments like this. There's these strings that I've put at the beginning of each function, and that's called a doc string, and you can see I've done that with 3 double quotes and 3 double quotes there. You could have used 3 single quotes, that also would have worked. Then I've put a summary of the function, then I've left a blank line, and then I've put more of a description of the function there, and that's the first string in any function is actually a doc string, and that's what my comment says. So that comment isn't actually helping for the function, it's just helping you understand what's going on. Similarly, you could do it this way. You just have a single line doc string, which I've done for those two. Wow, that was a lot of stuff. Let's run it and see what we get. So the first thing is time zones for region Australia. So that's those ones. That looks like a similar list to what we had before. The next one is New Zealand. Yep, that's what we get. The next one is ETC. Yep, and they're there. And the other one's UCT. which is UTC time. Now I can never work out why they do UCT or UTC. All right. Then I've got a list of all the time zone regions. So that's that. So that works with this new function we've got, which is just a one-line function. And then we've got help on the function region for time zone. So I've used the Python help function, and I've passed in my function name, region for time zone, and Python's returned help on that. It's saying this function's in the module called main, which is what your main module is always called by default. Gives the name of the function, the name of the argument, gives the one-line summary, and any several lines of description about how the function works. So doc strings are a great idea because you can then, other people using your functions can just call up help on your function and see how to use it. And how much more have we got to go? Oh yeah. Just a note of warning here when you're using ETC. I always get confused with these. ETC GMT -10 is the one that is actually Brisbane time, even though Brisbane time is GMT +10. So they're obviously saying that GMT is 10 hours behind Brisbane, and that's how they're labeling it. It's a bit obscure, but just be aware of that. So you can see current time in Brisbane 18:26, and GMT -10, ETC GMT -10 is 18:26. You see here I've used UTC, so obviously you can use UTC or UCT when you're doing time zones. Help can be called on built-in functions as well. So there's help on print. So it tells us there's the values we want printed. We could have commas and separate several of them. We can specify what we want the separator to be, what we want the end of the print statement to be. You want it to be a new line, which is the default, and some other things as well. All right. So the arguments to a function you can call either by the order. When you've got more than one, you can call them by the order that they're defined, or you can call them by their names, or both. So for example, here's a function, total seconds. We'll say the two arguments, the two parameters there are going to be minutes and seconds, and we can convert that to a total number of seconds. I've also put in default values there of equals 0, so if someone doesn't put in a value, that's what it'll use. So let's run this and see how total seconds works. So total seconds 32:15, so that's 32 minutes and 15 seconds, and the result for that is 1,935 seconds, and we called that by order. Now we could also call it by name, and when you're doing it by name, the order doesn't matter. So we could do seconds first. We could say seconds equals 15, minutes equals 32, and we get the same answer, 1935. Now you can call by order and name, but you have to do all the ones by order first. So we can do that one without a name, so that's going to be minutes, and then in this case there's only one left, so it's seconds, but if there were several left, it would just choose the seconds argument from that, and then all the optional arguments would just use their default values. Alright, so our task is expand total seconds to take 3 arguments, hours, minutes and seconds. Okay, and so that's pretty simple. We just add in hours equals 0, so it's got a default value, and return hours times 3600 plus minutes. Okay, so let's try calling our new function with a new argument, even though it's an optional one. So we'll define our function. So total seconds 32:15. That's now giving us a different answer, and that's because we've changed the order of the parameters. So that's a problem. You can get around the problem if you always specify the names when you're calling the functions, 1935, or if you do want to add new parameters to a function, existing function, then try adding them to the end. But in this case, it really makes more sense if you can put it at the beginning. So we just have to search for everywhere we've used that function, and hopefully no one externally is using it, so that we can add in hours into our list. Or we could say don't allow. We could disallow calling by order and enforce calling by name. All right. Solution 6. 3 named arguments to total seconds, and you can see that we've got some more examples. Here's one where it calls the hours equals 1, and that worked. This one worked as well. All right, task 7, define a function which converts temperature in Celsius to Fahrenheit. All right, so I'll just call it var, and it takes a variable c, which is a Celsius value, and it just returns c times 1.8 plus 32. And let's find out what var of 0 is. So 0 degrees Celsius is 32 degrees Fahrenheit. A very simple function that we created, and here's our solution. And I've done a loop here that's going to loop through a few different values in the list and calculate what our Fahrenheit is for each of those Celsius values. And 0 degrees Celsius is 32 degrees Fahrenheit, 100 degrees Celsius is 212 degrees Fahrenheit, and the magic number minus 40 degrees Celsius is actually minus 40 degrees Fahrenheit, which I always find surprising. Okay, so that's it for our session tonight. I hope you've enjoyed it. Any more questions? There's no more questions there. I'm going to quit now, and so the YouTube chat's going to stop. So, but you can keep asking questions on Slack, and either I or someone else will answer them when they if they see them. Okay. So next week is going to be machine learning taken by Arun, and that'll be online as well. Yeah, Gupta says he wants to understand time zones. Yeah, so time zones for tonight, the time zones were really just there for helping us work through a bunch of strings and doing stuff with them in functions. But if you've got a specific question about time zones, certainly ask that question. Yeah, so Arun's taking next week online. I'm taking the week after online, which will be so the 15th of March, and we'll look at how to send emails from a Python program. Then the 22nd of March will be online, and Arun doing machine learning again. And then the 29th of March is our next in-person event. It's at Brisbane Business Hub, which is in Queen Street Mall, 155 Queen Street, level 2. So we'd love you to come. It's getting more popular in there. The numbers have just been growing very quickly, and so it's really good to everyone to get to meet each other. And I hope to see you there if you can. That session is on Meetup already, so you can start RSVPing to it, and so we can get an idea of numbers. There's even a rumour there might be pizza, but we've still got to confirm that. Thank you very much.